Hello everyone, this is Hajing Tian. In this video, let's learn 3.2 applications of radian measure. All right, let's see what is the arc length. If I have a sector, I know this is the center, and then the sector, the arc length is here, and I know the radius r. We can list the relationship between the theta r and the secular length is S equals r times theta. Theta is in radians. So the arc length equals radius times theta, the angle theta in radius. Let's see the first one. Example 1. A circle has the radius 18.2 centimeter. Find the length of arc intercepted by the central angle having each measure. Round to 2 decimal places. So the first one, the theta is given. Theta equals 3 pi over 8. Let's find the arc length. S equals r theta. And r is 18.2. Theta is 3 pi over 8. Now we use our calculator to find this one. Okay, so 18.2 times 3 pi, 3 second caret sign, that's pi, divided by 8. Then hit enter. Okay, let's put the solution here. We're having 21.44136986. This is centimeter. The question says round to 2 decimal places. So I will ignore the rest of them. I'm having 21.44 centimeter. Okay, let's see next one. We are using the same formula, S equals r theta, to find the arc length. But now let's see, is the theta 144 degrees in the radian mode? No, this is a degree, not a radian. How to convert the degree to radians? Oh, I remember that. I need to multiply by pi over 180 degrees. So I will have an angle without the unit. So what is that? We should use a calculator. We are having 144 multiplied by pi times pi to second caret sign, that's pi divided by 180. Hit enter. Let's put the solution here. It's about 2.513274123 something. So we plug this one into the formula. S equals r times theta. R is 18.2 times the theta. We don't need to round the solution here because this one is not the arc length. This is the angle. So we don't need to round it at this step. So use 18.2 times theta. This is the theta. Let's multiply by 18.2. So we're having 45.74 something. So let's put the solution here. Is 45.74158,904. Round 2 decimal places. I'm having 45.74. So what is the unit? This is a centimeter. So the arc length is centimeter. All right, let's see next part. Latitude. Before we jump into this part, let's see what's the definition of latitude. Latitude gives the measure of central angle with a vertex at Earth's center whose initial side goes through the equator and whose terminal side goes through the given location. So it's very confusing. For example, if this is the Earth, and then this is the equator, another side of the Earth, and then this is the center, and from here to here we say that's the radius of the Earth. And if I have a city here, for example, this is a Houston. I line up the center and the city Houston. The angle formed by the line here and formed by the radius here and the R here. This one we call the latitude. How to express this? So we say theta degrees north. So north from the equator. So I think Houston is about 29 something, 29 point or 27.9 something. I forgot, but this is the way how we describe the latitude of Houston, the city Houston. All right, let's read the question. Let's erase this and move to the question. The question gave us two cities. One is Reno, another one is Los Angeles. So the latitude of Reno is 40 north, 40 degrees north of the equator, and Los Angeles is 34 degrees north of equator. So, and the radius of the Earth is given is 6,400 kilometer. Find the north-south distance between the two cities. Okay, we assume that these two cities, so they are maybe one city is here, Los Angeles, and another city is here, is Reno. Okay. And we measure that the latitude of LA is 34. The latitude of Reno is 40 degrees. And we are looking for the distance on the surface of the Earth from Reno to LA. So when we see this one, do you feel this is a sector? Yes, it is. How to find the length, arc length of this sector? So how to find this? Oh, we have a formula. S equals R theta. Okay, if I have R, oh, that's the radius of the Earth. If I have a theta, I can find the distance from Reno and LA, Los Angeles. So what is the theta? Okay, we know that here is 34, here is 40. The difference between the latitudes, that is the theta. Okay, I can list as a theta. Theta equals, use the 40 degrees minus 34 degrees. That's 6 degrees. This is in the degree mode. I need to convert it to the radian mode and then use the section, use the length of arc to find the distance from these two cities. So the theta also equals 6 degree multiplied by pi over 180 degrees. So I have pi over 30. We have pi over 30 without the degree because this is a radian mode. And then what is the distance from the two cities? The radius of the Earth is 6,400 multiplied by the pi over 30. And then we need to put this into the calculator. Let's see, what is that? 6,400 times pi divided by 30. hit enter. So this is a distance. Okay, the distance is about 670.2064328 kilometer. But the question, let's see the question. Round to the nearest kilometer. That means I don't need to have these decimals. And the first digit is 2 is too small. It's less than 5. That means I can ignore them. And then the solution is 670 kilometer from Reno to Los Angeles. Okay, so that's how the Google Map or Apple Map would count the distance from a city to another city. All right, let's see another example. Example 3, how many inches will the weight in the figure rise if the pulley is rotated through an angle of 80 degrees 50 minutes? Okay, so this pulley is rotating this way, for example. So my weight is going up. And the question is asking how many inches will weight will the raise the weight in figure rise. So that means, for example, I'm from this here and then move up this distance. So also my pulley will rotate. So from this point to the point here. So rotate this distance equals the distance of the this weight raised. So for example, I call this S, and then the point here to here also is S. Oh, that means another way to ask you, what is the arc length? Okay, if I'm looking for the arc length, I need to have r theta. Do we have r? Yes, it says the radius is 8.98 inches. And what is the theta? Theta is also given. Oh, that means I can find my S equals r theta. And the theta must be in the radian mode. So the first step, I must leave some space here, convert my theta into the radian mode. So we have 80 degrees, 50 minutes. How to convert it to the radian mode? So I know that if I have some degree, I need to multiply by pi over 180 degrees. So degree cancel, I got the radian. But this one, this angle is not the pure degree. It has a minutes here. That means I need to convert it to the degree, all of them the degree, and then convert it to the radians. So let's break down the 80 degrees and the 50 minutes. I have learned that from the minutes to degree, I need to divide it by 60, then convert the minutes to degree. So let's use our calculator to find this. So I'm having 80 plus 50 over 60. What is that? Okay. Let's put it on the on our notes. It's about 80.83333 degree. So, and second, S equals R times theta. I'm not done because this is the degree. This is not a radian. And my radian theta also equals 80.8333 multiplied by pi over 180. So use this one, this answer use this one, multiply by pi, and then divided by 180 degrees. What is that? Okay, I got this. That's 1.410807.812. Let's put it here. So my theta in degree in the radian mode is about 1.410807.812. And then finally, I can use the formula to find arc length. The S equals R theta, and R is 8.98 multiplied by the theta. So I don't want to copy that because I have it in my calculator. So use this number multiplied by 8.98. What is that? Oh, did I hit it? Okay, I think I'm too much. I clicked several times. So use this one, multiply by 8.98. What is that? Oh, it's 12.6690 something. And then let's put it in the notes. So it is 12.66905415 something. And the question says, the first one is round to the nearest tenth. Nearest tenth is 6. Okay, so I'm having 12.6, oh, sorry, 12.7. So by the computation, did I change the units? No. So let's see. The radius is inches. So the radius is inches. The angle is no unit. That means my arc length is inches. All right, number B. Question number B. Through what angle? Let's do the number B here. Through what angle to the nearest minutes must pulley be rotated to raise the weight 7 inches. Okay, that means so the arc length S is given, and R, we have the R, and looking for the theta. And this theta is in the degree mode because nearest minute. Let's see how to find the theta. So divided by R both sides, S over R is theta. Let's find the radian measure first, and then convert it to the degree mode. So theta equals, put all the information in it. So it's, so this weight raised up 7 inches, 7 over the R. R is 8.98. So let's use our calculator to find this. And then later I got my solution. The theta, use this one, 7 over 8.98. So convert it to the degree mode. I'm having 180 degrees over pi. So I can make my degree. So I have my degree come out. So we can put all of these in my calculator. So I skip this step to find the solution. Okay. So I have 7 divided by 8.98, then multiply by what? That's 180 divided by pi. Second caret sign, close the parentheses. If there is no mistake, that is the solution. Hit enter. That's 44.66. So the angle is about 44.66263436 degrees. So the question is, round to the nearest minute. That means they accept the degree mode, but they also accept the DMS, degree, minute, and didn't mention about the second, just the degree and minutes. So I need to separate the degree 44 and the decimal part 0.66263,436 degrees, and convert this one to the minutes. So 44 degrees plus all of this, copy them again, multiply by what? 60. Then I convert to the degree to minutes. So that's 44. Oh, sorry. 44 plus what? So let's use a calculator to find the solution. So use this and go minus 44. Then this is the decimals. Convert the decimals to the minutes, multiply by 60. So that's 39.75 something. Let's copy this. That's 39.75 806186. This is the minutes part, and the question says only round it to the nearest minutes, so I cannot have decimals. If I have no decimals, I will look at the first decimal point. That's a first decimal digit is 7. It's greater than or equal to 5. That means I'm having my solution is 44 degrees plus 40. Here add 1 minutes. So this is 44 degrees, 40 minutes. All right, this is a long question. Let's see the next one. Let's make it big so you can read the question. You can pause the video and read the question. So this question, we have 2 gears. So 2 gears, they are adjusted so that the smaller gear drives the larger ones. As shown in the figure, if the small gear rotates through an angle 300 degrees, through how many degrees will the larger gear rotate? Okay, so my smaller one is rotating this way, for example, and then the big one will rotate this way. They will contact these areas. Oh, that means the surface by the rotation will keep the same. That means, maybe the surface, the smaller one, the surface rotates, the arc length rotate for 5 centimeter, and then the big one also rotate 5 centimeter, because the surface, they connect to each other, so they rotate this way, small one, and the big one rotate this side, and the surface are the same. That means the arc length is the same. All right, what the question is asking? Oh, how many degrees will the larger gear rotate? Let's list the 2 relationship. So for the small gear, the arc length S equals R theta. And for the big one, I also have this formula S equals R theta. Maybe I say different R because they have different R. R sub 1, R sub 2, theta sub 1, theta sub 2, and they have the same S. That means the S part are the same because they connect to each other. And the given information is R1, R2, and also theta 1. So theta 1 is 30 degrees. So theta 1 is 300 degrees. I need to sleep, right? 300 degrees. So convert it to the radian mode. That's 300 degrees multiplied by pi over 180 degrees. So degrees part canceled. What is this? Degree and the 0 canceled, and they are all divisible by 6. Divided by 6 is 3. Divided by 6 is 5. I'm having 5 pi over 3. This is the angle 1 in the radian mode. So the S equals R1 is 3.1 centimeter times 5 pi over 3. And also, this is the arc length of the big gear. So the big gear, 3.1 times 5 pi over 3 equals R2, 7.5 times theta 2. Can you solve the theta 2? Yes, we can. Theta 2 equals all of them. This is the S part, 3.1 times 5 pi over 3 divided by 7.5. Let's use our calculator input this complex expression. So let's use some parentheses because we have a lot of things to input. So on the top, I forgot what's on the top. Let's go back. Okay, I think I can remember that. So 3.1 times 5 pi 5. I click the clear. On the top is 3.5. 3.1. 3.1 times 5 pi. 5 second caret. 5 pi divided by 3. And then all of them divided by 7.5. 7.5. Okay, let's hit enter. Okay, that's 2.1642 something. So the theta 2 in the radian mode is 2.16420872. And then we need to convert it to the degree mode because it asks how many degrees. So you can convert this one to the degree. So the theta 2 converted to the degree mode. What should I do? I need to use this one multiply by 180 degrees divided by pi. So let's use this one multiply by 180 divided by pi. Oh, it's 124. What is the unit? 124 unit. Sorry, 124. The unit is degree. All right. So we solved this one. What is the next? Area of a sector. We talked about the arc length. Now, arc length of a sector. Now let's see how to find the area of the sector. Let me ask you, if I have a circle and then I have a radius, the radius is r. What is the area of this? The full circle is pi r squared. We have learned this one before. I think maybe in your high school or in other math class, fundamental math classes. So how about now? I want to find the half of this circle. So I know that's what is the angle of the half of the circle. Oh, that's pi. So that is the pi out of 2 pi because pi over 2 pi, that's the half of the full rotation or full revolution. And also that is the half of the area, right? All right. So I use this ratio multiply by the whole area of the circle, pi r squared. And then I'm having 1/2 pi r squared. Oh, if I have a theta, for example, this is theta. I want to find the area of this sector, area of here. So how to do that? I can use my theta. Out of the full rotation, or the one revolution, 2 pi, and then multiply by pi r squared. That's the area of the circle, and then I can find the sector's area. Then do the cancellation. Pi canceled, and then I can move the 1/2 in front. 1/2 r squared theta is the formula to find the area of the sector. All right, we proved how we found the area of the sector. That's 1/2 r squared theta. Theta is in the radian mode. All right, number 5. Find the area of a sector of a circle having radius r and the central angle theta. Oh, that means I have a circle, and then I know the theta is 100 degrees. That's too much, too small. For example, here. So I know the theta, I know the r equals 70 miles. So how to find the area of the sector? That's 1/2 r squared theta. Is the theta in the degree mode? No, theta is 100. So 100 degree. So I convert it to the radian mode. So 100 degrees times pi over 180 degrees. Do the cancellation. I'm having 5 pi over 9. Yes, it's 5 pi over 9. All right, put it in the formula. I'm having A equals 1/2 times R. R is 70 times 5 pi over 9. Let's put this information in our calculator. So clear the board. I'm having 1/2, 1 divided by 2, then times 70. So 70, use parentheses, 7 squared. You know which button I clicked? X squared, this one. Okay. Let's delete that. And then multiply by, there is a fraction, that's 5 pi, 5 times second caret 5 pi divided by 9, close the parentheses. So we're having, well, this is a big number, 4,276.0566. So the area is 4276.056667. So if I need to round it to, this question didn't mention. So for example, let's round to nearest tenth. So let's see, the tenth is 0. I'm having the solution is 4276.1 and square mile. All right, let's see the last question. A circular sector has an area. Oh, area is given. So let's see. Area is given. It's 12 square inches. The radius of the circle is 2. R is 2. What is the arc length of the sector? Oh, the question is asking the arc length. Arc length, we learned that the formula is S equals R theta. Do we have R? Yes, it's 2 inches. Do we have theta? No, we do not. But it told us that the area is 12 square inches. That means I can find my theta because the area equals 1/2 R squared theta. So A is given, R is given, only theta is unknown. Can you find theta? Yes, multiply by 2 both sides, 2a, and then divided by r squared. That is theta. So if we find the theta, can you plug it in the formula, find the arc length? Yes, we can. So let's see, what is theta? So theta equals 2 times a, 2 times 12 divided by r squared. R squared is 2 squared. I'm having 24 divided by 4 is 6. So my theta is 6. And then bring it to the formula, S equals R times theta. R times 6. So the S equals R is 2. 2 times 6. S equals 12. And this one, the unit is inches. So the arc length is 12 inches. All right, we're done for today. I hope you have a good day. And if you have any question, please let me know. See you next video. Bye. Have a good one.